Welcome to our today's video on DHCP Failover Service, where we will dive into a critical network service that ensures high availability and reliability in your DHCP environment. Whether you are a network administrator or just someone looking to understand how DHCP can be more resilient, this video is for you. By the end of this tutorial, you will understand what DHCP failover is, how it works, and how to set it up to ensure the uninterrupted service across your network. Let's get started. My name is Navneet Kumar and I'm a Microsoft certified trainer. The learning objectives of this training video are: what is DHCP failover, how DHCP works, benefits of DHCP failover, real-world scenarios, and finally a demonstration on implementing the DHCP failover. First thing first, what exactly a DHCP failover is? In simple terms, it's a redundant setup that ensures your DHCP service remains up and running even if one server fails. When you set up DHCP on your network, a DHCP protocol server assigns the IP addresses to the devices like the computers, phones, or the printers. Now, imagine if that server goes down. Suddenly, the devices can't get IP addresses, leading to the connectivity issues. That's where DHCP failover steps in. It allows two DHCP servers to share their lease information, ensure that if one server fails, the other can take over, keeping everything running smoothly. Now let's talk about the DHCP failover working principles, how it works. We have two different methods in which we can configure it. Number one is hot standby, or you can call it active passive, where one DHCP server remains active but the other is in passive state. It is only there to take over if the primary DHCP server fails, like a typical failover option or failover method. Whereas we have the second method, which is load balancing. This is active mode, where both DHCP servers are active and they are actively exchanging the information of the IP addresses they have leased so that there is no conflict. We also can dedicate the percentage of IP address pool, that how many IP addresses can be assigned by each DHCP server. They not only offer the high availability but also the load balancing. Well, if we compare the hot standby mode and load balancing mode, the first thing is purpose. It provides failover redundancy, whereas the load balancing distributes the DHCP requests across both the servers. As far as the server roles are concerned, one server is active, the other one is on the standby mode. In load balancing, both are active. Failover behavior: the secondary server takes over if primary fails. In load balancing, both servers continue to handle requests even if one fails. IP address assignment: only the primary server assigns the IP in the hot standby mode, whereas in load balancing, both servers assign the IP addresses and balance the load. Client response time: slightly delayed during the failover, whereas faster response time due to the load distribution in load balancing mode. As far as redundancy is concerned, high redundancy with one active server is there, whereas in load balancing, continuous redundancy with both servers active at the same time. The hot standby is best for simple setup, minimal load on the secondary server, whereas the load balancing mode is good for high availability and better load balancing management. Now let's talk about the benefits of the DHCP failover. Number one, it increased the reliability. If one DHCP server fails, the other is there to take over immediately. Number two is improved redundancy. With two servers running, the chances of the complete failure are mitigated or reduced. Better load distribution: in load balancing mode, the workload is split across these two servers. This reduces the strain on any single server and improves the overall performance. Next is minimized downtime. Even in the event of a server crash, your network remains unaffected. Now let's talk about the real-world scenarios for the DHCP failover. Number one is enterprise network, where it ensures the high availability for the DHCP service in the large corporate environments where the network uptime is very crucial. Next is data centers. It provides redundant DHCP services in data centers for the servers where the crucial applications are running on servers. Healthcare networks in hospitals and medical facilities, DHCP failover ensures that the medical devices and the network equipments remain connected and operational. The educational institutions in the universities or schools where many devices like the laptops, tablets, or the IoT devices are connected, the DHCP failover ensures the uninterrupted IP distribution to these devices. For retail network, we can use it. We can use it for government and public sector, where we can ensure the reliable network operations for government offices, public services, and for emergency response systems as well. As far as the telecommunication providers is concerned, for telecom companies providing the managed services to the customers, DHCP failover guarantees the service continuity. The cloud and hybrid network environments. In hybrid cloud setup, the DHCP failover ensures that the devices and the virtual machines across on-prem and the cloud networks can obtain the IP addresses seamlessly. Remote work environments. For organizations with the distributed workforce, the DHCP failover ensures that the remote office location have the continuous network connectivity even if one server experiences the issues. Finally, we can use it for disaster recovery plans. As part of the disaster recovery strategy, the DHCP failover provides the redundancy for critical network services. It ensures that the IP address management or assignment continues even during the hardware failures or the server outages. Now let's get into the demonstration to understand how to set up the DHCP failover service. To set up the DHCP failover, I will connect to one of the DHCP server in this Active Directory domain. For that, I will go to Server Manager and the DHCP Management Console. In this DHCP Management Console, I will add the first DHCP server. We'll click on Add Server. I can connect to this authorized DHCP server that you see in this network. I can check this box and add this to this DHCP Management Console. This is Seattle DC1. It has one IPv4 scope configured already. You will see this scope by the name Contoso in 172.16 range. There is an IP pool also from 160 to 190. The 30 IP addresses will be leased by this DHCP server. So this DHCP server is there, but this DHCP server, as you see with this scope, but here you see the red button that it is actually not active, you can say, because after the DHCP installation or configuration you have done, you have to authorize the DHCP servers. You have the option to create the scope, super scope, multicast scope and all. So you need to make it authorized in the Active Directory domain environment, because if the DHCP is in a work group, then it can start leasing IP addresses immediately. But in Active Directory domain environment, we need to authorize that in the Active Directory domain to make it a legitimate DHCP server to lease the IP configuration to the network devices in the domain. It is actually for the security purpose. This is now turned into green as soon as I authorized this DHCP server. As you see, now we have one server which is completely ready. I'm going to install one more DHCP server in this network. For that, I will go to Server Manager, will choose my server, that is Seattle Server 1, and on that Seattle Server 1 I will install the DHCP service. There we go. Well, this DHCP service is installed. Now let us authorize this DHCP server by completing the DHCP configuration. It will do two things. one, it will create two security groups, one for DHCP administrators and second for DHCP users to delegate the permissions, and it will authorize this server also in this Active Directory domain. Now I will add that DHCP server. And this is Seattle server1.contoso.com that I will add to this DHCP management console to configure the failover. Well, this server has been added. As you see, 172.16.10.12 server is there and it is authorized. It's turned into the green color already. And here you see IPv4 and IPv6, both options are there. But this DHCP server has no DHCP scope or the configuration done so far, as we have done this installation from scratch on this second server you have seen. Now to configure the DHCP failover, either I can right click on the IPv4 and configure the failover for all the scopes, or if I have a single scope, then I can configure the failover for a single scope. Then I will select next and add the partner server to whom I want to replicate this DHCP server scope. I will add that Seattle server 1 into this partnership list. I will search for Seattle server 1 from the Active Directory computers database and will click OK. And here I will select next. And I will get the configuration for the DHCP failover, like the relationship name, where I can provide a friendly name for this DHCP failover. Next is the maximum client lead time, MCLT, which is actually to take the control after 1 hour if the one DHCP server does not get a response from the second server. Then it is hot standby or load balancing. In hot standby, the second server will remain on the standby. So you can decide that the role of the partner server is standby or active. So which will be active and which will be passive. And then address reserved for the standby server can be configured. Next is load balancing, where I can define the load balancing percentage. For an instance, we are leasing the 30 IP addresses, so 15 IP addresses are provided to each. This is the shared secret that I will enable message authentication between two DHCP servers before they replicate anything. So that is the handshake process that will happen between these two DHCP servers in this replication partnership. The add scope on the partner server is done and rest of the configuration is also done. So replication has happened. All you need to do is you need to refresh this console and you will see the DHCP scope replicated to the second server. This is how we perform the DHCP failover, and I hope this was informative to you.